My name is DaShaun. I'm going to do a little selfie thing here. Like, can you guys say open source on 3? 1, 2, 3. Open source. Oh, thank you. Thank you. I get that from my good friend Josh. He likes to do that. Josh Long. Can you guys see my screen? So, full disclosure, I changed this morning. So, what could possibly go wrong? I changed it. Let's give it a go. I changed it based on what I saw. This has been a great, great conference. Ken, thank you so much for inviting me. This has just been wonderful. So I'm going to try to kind of fill in some of the things that I didn't see a whole lot, and we'll talk. But my mode is really ask questions along the way. So you don't have to wait till the end. Who knows how long it's going to go? Who knows if it's going to fit or not? But yeah, the thing I want you to take away from this is that my children, 4 of them, will never deploy active passive. That's the main thing. If you take nothing else, just know that my 4 children will never deploy active passive. So this is me. Today is day 479 in this role as a Spring Developer Advocate at VMware Tanzu. Before that, I've done some things. I did work at Redis. You'll see my bias in a little bit. I worked at VMware before working at VMware. They call it a boomerang. And I was a VP of engineering for a little fintech startup, and I worked for a company you may have heard of called Garmin. That was my longest tenure. You can find me on the Twitters and GitHubs and GitLabs, all the places, and LinkedIn. And my favorite hour of the week is Spring office hours. I'm a Spring Developer Advocate. If you are doing anything with Spring, this is the thing that I wish I had when I was an IC, when I was a developer. I wish I had a way to go and ask questions. I don't have all the answers. This is my partner, Dan. He does not have all the answers, but we've got Slack. And we've got the Spring team on Slack. So anything that you've got related to Spring, bring it. Open office hours. It's at 3:30 p.m. Eastern on Tuesdays. Just about every Tuesday. You can come in. It's a live stream. Ask your questions. The community is great. That's your invite. Office hours. How many of you have ran game day exercises? Meaning, let's go ahead and shut down that region and see how things work. Or inject chaos or any chaos. So I see a few hands. That's wonderful. Like, these are cool things, because in my last, 4.5 years, 5 years, worked with Global 2000s, Fortune 500s, where sometimes it's surprising, sometimes it's not. They've never ran a game day exercise. Oh, yeah, we do all the cloud-native things, but we've never really tested it. So that's kind of in my head. I was in that position. Oh, and again, my children, I'm not saying anything about what you do in your house. My children will never deploy active passive. Uh-oh, I had the wrong button. So let's level set. Let's talk about some of this stuff. A zone. Single region, logical data center with its own power, network, cooling resources. Is that a good enough definition? Let's just use that one for the rest of this session. A region, collaborating zones. I'm going to say that in my house, I've got zones. I've got 3 ISPs coming into my house. Each little section, I've got different circuits. The cooling's not so much different, but I'm using ARM64, Raspberry Pis, so the heat's not such a big deal. Okay? But I've got these different setups, so I can do some interesting things inside my house. And I'll use that term loosely. I have zones and regions in my house. But this is what it looks like. Zone. Power. Network. Cooling. Might be in the same building. That's okay. It might be a different building. We want to be close-ish. It depends on who you ask. Comfortable with those terms, zones, regions? Good. We like that low latency. It's 2023. A lot of us are global. Or if we're not global yet, we're hoping to be global at some point. And I like to say latency is the new downtime. I don't want things to take forever, right? Too much latency, it might as well be down. One of the other things, and I'm going to scoot through these slides because I want to kind of get to the meat and dig in a little bit. Resiliency is greater than robustness. What do I mean? I care more about it being up. I'm going to spend more time on things being up and having things recover. I don't want to answer the phone, period. I don't want messages or pagers or anything like that. I just want things to take care of themselves. To the point, there was a point in my career where I had automation that, hey, if that service fell over, I knew it was going to fall over. If that service fell over, just reboot it. That's cool. That's kind of what Kubernetes does, right? Like, hey, something's wrong. Like, just spin it up someplace else. I got in trouble for it, hand slapped. I'm very comfortable getting my hand slapped. I made my career, and I surround myself with people who have made their career out of making career-limiting decisions like that. Yeah. So, I have some Terraform. I deployed it because sometimes it takes a little bit. It takes a little bit of time. And I've chosen for this run through, I'm going to use Azure Spring Apps Enterprise, Azure Cache for Redis Enterprise, and Azure Front Door. Enterprise stuff, but we can do this exercise all sorts of ways. I've delivered this type of a presentation in dozens of ways. All the clouds, all the Raspberry Pis, all the things. Terraform. I'm going to show you what I've deployed. My whole presentation also. I don't care. Oh, here, you can see it. This is live. I'm using DaShaun.com. My children will never deploy active passive. You can follow along, and you can actually hit the S button on your keyboard. You can see my speaker notes, which I can't see because I'm mirroring the screen, and that's okay. But the point is, I don't care if you, I would love it if you took this session and you made it your own and you delivered it. You have my blessing. There's an Apache or MIT license on the repository at GitHub. Like, I want you to feel like, hey, this is valuable. That makes me happy. So in anything that you've seen me deliver, be comfortable taking it, making it your own, and it's all in Markdown. There's a project called Reveal.js that I use to kind of do this. I'll show you I have this two-dimensional slides. So if I run out of time, I can scoot across the top. But if I got time, I can go down, I can drill in a little bit. Reveal.js, I love it. So Terraform, it's this language. I like to do infrastructure as code. I'm going to jump over and show you what I've deployed. I'm going to hide that. And I've got a Terraform repository in here. And I'm just going to show one. I've got resource groups. This is a logical construct inside of Azure. I've got a default group up here. And I've got one for Acre. Acre is Azure Cache for Redis Enterprise. I'm the one that came up with that. It's awesome. You're welcome. And Acre 2. So I've got 3 different resource groups where I'm going to put things in the cloud. And I'm using Terraform to deploy it. Anybody familiar with Terraform? Terraform users? Happy? Yes? Good? All right. Terraform also has these new SDKs, so you can deliver in your favorite language without using HCL. I can deliver it in Java. I've done that as well. But I'm just going to stop there. Terraform, this is what it looks like. HCL. Here's an example from my past where I've got data in one region. Remember, Acre is Azure Cache for Redis. It's just a data store. It could be anything, especially in this case, where we've got a data store. We're doing some things. It's taking traffic. It's reading data, writing data, all the things. And I created a function, this export function, that says, hey, go ahead and dump that database. Call whatever I need to on that database, dump it, get a snapshot of that database, however you want to do it. And that, it's in github.com/redisgeek. Also me, but you can get that function. It's a Spring Cloud function. When it does that, it stores the output into a blob container, S3 bucket, for example, and it just says, hey, here's a dump. I've got it. And I've got something that's watching that container that says, hey, when you get new data, I want to copy it over. That copy function sends it, but I'm going to send it to a different region. In case something goes wrong, wherever this is being run, in your home lab, in your data center, whatever, just this idea. This is an active passive. Like, if something goes wrong in primary region, I want to make sure I've got a backup somewhere else. And this is a snapshot example. We could do things like change data capture. We can make it a little bit more advanced than this. This is just an example, and all the source code is available on GitHub. Does that make sense? Functions all the way down? At one point in my career, I thought I was doing the organization that I worked for a big service. Like, I was like, look, I'm saving you guys money. I'm just going to spin up one VM running MySQL and problem solve. Like, I'm not going to go overdo it. Like, my thing is going to be fine. It's tiny. It's a tiny little thing. And then if you stick around long enough to see the outcomes, you'll find that decision that you made years ago of that one VM for that one MySQL server, now it's in production, now it's critical. And we got to take an update, or a CVE happens, or whatever. Anybody else been in that? Just me? You guys are way smarter than I. Like, this is a problem. So one organization that I worked with, they're like, we've been burned by that enough. Bare minimum, you don't get to deploy a single instance of data service. The bare minimum is going to have some level 3.9's SLA. The bare minimum that you can get running on this platform is a leader-follower pair. Wow, they were forward-thinking. This is where it starts. Like, I was like, this is nice. We're doing things. Inside of a region, I've got leader-follower pairs. So if something happens to that primary node, it flips over. Now my follower is my primary. That's magic. That's cool. We've been doing that for years, though, right? There's options. If I've got a leader-follower pair, I can split things out. I could use that follower as reads. Primary for the writes. I want to get all those writes, but I could read from both. I can spread out some of the load. This is interesting. I'm actually getting some capacity, some performance improvement, just by doing this leader-follower pair in the same region. Right? Head nods. Glad that's. Anybody doing this today? Leader-follower pair real easy? Yeah. It's not too hard. In a single region, leader-follower, make sure they are in different zones. That's the key. Like, don't put your leader-follower pair in the same closet in the data center, in the same rack in there. Like, give yourself some room. Still, we want low latency, but give yourself some room in case something happens, a fire or a sprinkler, in my case. I had a data center in my basement, and the lawnmower guy is coming out and he rode over the hose that we used to water the lawn. And in my basement, I had the racks. Little did I know that the hose that connected to the outside was inside of my little room with the data center, and split just enough on that pipe where it sprayed across the whole data center. It was good. So good. Good times. Nobody died, so that was good. This is what active passive looks like. Let's take some traffic on the good side. And we're doing the copies or change data capture or whatever it is to some other place, some other region. Not in your basement. And when things fall over, cool, switch. And sometimes that switch can take some time. So I've also worked in companies, head nods, yes, you understand where I'm coming from. We weren't doing the game day exercise. It's like, hey, yeah, data center one, he's having some problems, power or internet, either one. So let's just switch over. And this is where we do like that clock, like hours later. Yeah, yeah, customers are fine. Failover worked. It was hours, right? It's 2023. That's probably not going to cut it for anybody in here. But yeah, I'm sharing. This is kind of a therapy for me. You know, it's good to talk about the things in the past. These are things I don't want you to run into. Really, I don't want you to run into these things. Active passive, like it's better than one. This is brilliant. Like, yeah, we'll just do the active passive thing. Like, copy the data, and if something goes wrong, you know, some time later we'll be up and running. Yes, absolutely. Solves all our problems. Only costs twice as much for infrastructure. Right? High watermark. Hey, make a copy of it. The infrastructure guys love that. Your hardware vendors love it. So does Amazon and AWS. Like, they all love it too. Great, do this. Right? So pay attention. Just make it happen. Right? Make it happen. If this is what you're thinking, yeah, make it happen. Quotes from former VP of engineering. Former. Latency is the new downtime. That 4-hour cutover, however long it took, that cutover, it didn't make me feel good. I like to kind of feel like I've got the pulse of the customer. I like to be like the customer's champion. It didn't make me feel good. So there had to be a better way, right? It's got to be. My children will never deploy active passive. They just won't. Again, I don't care what you do in your house. I'm just saying. I have scar tissue. Is your app alone, trembling in the dark? And this is what I felt. I felt like my app. I just knew it was going to happen. Right? I knew it was going to happen. Hey, we have this 2 data center, and we've already dealt with a failover that we've never tested. Right? Even though we fire up the generator, like we had the backup generator, we fire that up every Friday, but never once were we testing this cutover between the data centers. Like, why didn't we just do it every Friday? Again, pain therapy, thank you guys. I do feel like this is a safe place. The whole conference has been a safe place. But I felt it, as we were growing, as we were adding customers, adding devices, everything. I felt that it was going to happen, and I didn't like that feeling. Did you have a question? No? Okay. Again, I said that, yes. Outages, money lost, trust lost, momentum, sleep, all those things. It doesn't happen every day. Yeah, it'll happen someday. I probably won't even work here anymore. No big deal. Here's the thing. Active, passive, there's the cost part, and this is really the thing that I'm trying to instill in my kids, is there's two organizations where I was the one that was responsible for the bill. And I saw that, hey, we're coming up to the holidays, right? This data center can handle us at high watermark capacity, great, but so can that one. And I'm paying for that one. I'm paying the exact same price for that one, except for one little change on the network. I'm paying the exact same price. And I've been through that twice, where I was paying for this additional infrastructure, and I couldn't use it because of policy. But I also told you I've made my life, my career, out of making career-limited decisions. So active, I can get that additional capacity. I can feel a little bit more confident coming into the holidays or whatever high water mark of the year it is for you. But also the resiliency. The resiliency wasn't just about holiday time and massive things are happening and we're going to get overwhelmed with traffic. Resiliency also around upgrades, software pushes. That was a big deal. Hey, the whole don't deploy on Friday. If I'm doing this active thing and I've got something like Kubernetes, I've got advanced deployment strategies available, I can do canaries, I can do these things, then deploy whenever, right? I can move to this model without additional infrastructure. So I'm going to get all this bang for the buck. I just want to use that data center over there that already has all of the infrastructure. It's ready for the high watermark, right? Because we've already scaled it up. I got a duplicate copy of everything, ready for the high watermark, but I'm just not using it, and I just really want to use it. So what is that going to take? Yeah, if you're upgrading from active, if you've only got one data center, okay, what are you going to do? I hope already you're not going to think about doing the active passive route. All right? If you're moving, you're growing, you're scaling, start with one. Start with one. But when it's time to move to two, just remember this. That's all I'm saying. That's all I'm asking. No? No hands? Oh. We got one. I don't. That's all. I'm cheap. I don't like to do that. And I'm coming from a weird place where I've done the development, but then I was in this role where, hey, this is your bill. I had one leader who was like, hey, if we're going to move from the data center to the cloud, you got to make it cheaper. You got to prove it to me, numbers-wise. So this is completely off track, off script. This cloud's not cheap. It's not cheap. Data center, buying the 3-year commit on a data center, way cheaper. You just got to know how to use it. You can't move as fast. But one of these things, hear me now, listen to me later. Cloud can be affordable if you clean up behind yourself. One of the reasons I like to use Terraform. For this example here, I'm going to stand up this infrastructure declaratively, hey, here's what it looks like. And when I'm done, I'm going to do Terraform destroy. And it's gone. So I'm paying by the minute or by the second or milliseconds if you're using Cloud Functions in some case. Clean up behind yourself. Again, listen to me now, hear me later. I don't like paying for infrastructure that I'm not using. Just think about this. For our little small dev team, Everybody gets a cloud instance, cloud VM or cloud Kubernetes cluster, whatever, from 8 to 5, Monday to Friday. Does two things for me. I know how much it's going to cost, and I can kick people out. Oh, sorry, your infrastructure's, you get a little warning at 5 minutes to 5, your infrastructure's going away. I don't want you here more than 40 hours a week. Again, hear me now, listen to me later, but it was cool, right? Versus having a shared dev environment that's up 24/7. Versus, like, here's the other thing, our QA environment. We had a QA team, we did our thing. QA team, their environment got stood up, considering like something like Terraform. Stand up the QA environment and it would stand up for 4 hours. You've got to get through your tests in 4 hours, and if you can't, why? Like, we're a startup, like, here's what we're doing. You've got 4 hours to do it, and if you can't get it done in 4 hours, it comes out your bill, not mine. Why would the QA environment be up if you're not using it? Okay, I'm going to get back on track. That was totally, oh, yeah. So, stop doing this. Stop doing the active passive. Don't do it. I don't even, like a lot of people in here, they're like, I don't even know what active passive is. I don't even know why I told you. I told you so you don't do it. Don't do it. No. My children will never do it. Never. My children will never deploy active passive. They know. Get the switch on. You've got options. There's lots of ways to do this active-active approach, this high resiliency model. There's tons of ways. Maybe I'm a little bit old school, right? There was no service mesh back in 2008 when Facebook was millions of users, right? How did they do it? What were they doing? How did Facebook get your thing, your message, over to Asia? Like, what happened? Anyone? There's a data tier. They're using Cassandra, right? Hey, we're going to write it here. Eventually, consistent, it'll show up over there. You have options, right? Maybe that's not good enough. Maybe we need locks. We need distributed locks. We need transactions. So you have different options. Cassandra, I've done this demo with Cassandra. Yugabyte, I've done this with Yugabyte. Today I'm doing Azure Cache for Redis Enterprise. But you've got options. And it depends, right? Just like, should it be an RDBMS or should it be NoSQL? Like, you've got to make some decisions. I'm not going to do all the work for you. But if you've got standby infrastructure, I want you right now to start, put it on the roadmap. Put it on the roadmap. Let's convert that standby infrastructure into active infrastructure. I like it when I see head nods like that. That's easy. You're paying for it already. You're paying for it already. You've got standby infrastructure. I know that if you can convert that standby infrastructure into active infrastructure, come leadership, come the engineering all hands, you are going to get at least a pat on the back. At least a pat on the back if you can do that. But it's all a negotiation. What are we going to do? Multi-region, multi-cloud. I'm going to race through these. We could talk forever. This is one approach. This is what we're doing under the covers here. I'm going to do a write over to region 1. Whatever shard it hits, it's got a replica. It's going to hit that replica. From the replica, in this case, I care about speed. Right? Redis is about speed. I'm going to hit that replica. That replica is then going to call over to another region, to its primary node. Okay? So you can see, hey, if something happens, if that primary falls over, my replica hops up, and it becomes the primary. And then it'll stand up a new replica, and it'll get generated, and then we're back to this model. Same. If my entire region falls over, cool, that's just right to the other region. Primary, secondary, it's got a full copy, we're good, right? And you can scale this out. That box is a shard, let's call it, but you can have multiple shards in a database. Does that make sense? This is just one approach. This is a conflict-free database. Conflict-free data types. One of the benefits of Redis is it has all these magical data types. A lot of people know the key value store, but it's got lots of really, really cool data types in it as well. This is what I'm trying to get to. This is what I want to show. active, active. So let's jump. I have taken a simple Spring Boot app. And if you're not a Spring Boot developer, I have to show you start.spring.io. I can go and bootstrap an application. I can say, hey, I want it to be a Maven. I want to have like some web stuff, and maybe I want to use Redis. And of course, I'm going to do an actuator because I want it to be production ready. Actuator gives me a lot of things out of the box. I can do that, and I can generate, and I can get started with an app. Cool, I'm not going to do that right now. I'm going to show you what I did. First thing I'll do is I'll show you my POM file. That's basically what we're going to get. I'm using Spring Boot 2.7. I'll explain why later. And I've got my cloud dependencies, my actuator, because I want it to be production ready, Spring Data Redis, Spring Boot Starter, that web, because I'm going to do some endpoints, starter config. Oh, and I've got test containers in there, but I'm not going to talk about test containers today. We're going to keep on going. So real simple, nothing magic. That was the POM, the dependencies that are going to make up this project. Then I've got a really simple project. Can you guys read that okay? Nothing magic here. If you've done Spring, Spring does a lot of the work for you. This is why I like it. I'm not a real big language nerd. I just like getting things to production. I don't know all the different benefits of upgrading from Java 11 or Java 8 to Java 17. I just know that Java 17 is so much faster. And that's why I like it. I can get to production. I can get a bunch of bang for the buck. Same code that I wrote against Java 11, I can put it on Java 17 JVM, better performance. I like that. I didn't have to do a whole lot of work. So, Spring Boot application, I put a little REST controller in. That REST controller wants to get some information from its context. It wants to get it from its environment. What region am I in? That's it. I got a controller. I've got an endpoint that says, hey, whatever region I'm in, let's just add a key. Let's drop one in. Cool? Simple stuff. And then there's one to show the list. So let's jump over. Let's see what that looks like. I've got this endpoint. That app deployed. I'm using Azure Spring Apps. Again, it kind of looks like this. That application bucket. It's Kubernetes under the covers, but Azure Spring Apps for Enterprise does a lot of really cool stuff. It could have been a VM. I could have deployed the same thing to a VM. I would have had to write a little bit more bash, and I didn't like that. So I'm sticking with Terraform HCL, Spring Boot. That's all that I've got to write. Azure Spring Apps for Enterprise, Terraform Apply. I've got a bucket. I've got a Kubernetes cluster to hold my app. And now we're going to get into build packs. So when I pushed this app, I didn't build anything. When I pushed the app, I'm going to show you this. This is the command. This is one of my cheat codes. I put all the command line options that I want that I'm going to run. I put them into a Terraform output. I just plug in the values. So I don't have to copy and paste anything. I just get it. So to deploy this app, Azure Spring App deploy, this is what it's doing into region 1. Here's the location to look for it, the name of the service, and then I'm just giving it source. The source path is that source code. Not a container, not a jar, it's the source code. And I say push, go. Just the source code. So I didn't have to build anything. The platform is doing it all for me using this build pack idea. How many people have used build packs? Build packs, we got a few fans. Awesome, you guys are getting to production faster. Docker, everybody understands Docker. So I'm going to make it real simple. A build pack is a Docker image that I can, it's got two phases, a detect phase and a run phase. So if I give it source code, in this case it's a Spring, and it's got a POM file in, so it says, hey, I see that. You got a POM file. That's a Maven project. So it says, oh, I know how to build Maven. But it does it all inside of this build pack. And I can have all sorts of things. I can put in my CA certs. I can attach APM. I can do all sorts of things in these build packs. But I can make it consistent across my organization. We like to say, friends don't let friends write Docker files. If you see a Docker file, somebody gives you a Docker file, you bat it down. Don't touch the Docker file, because if you touch the Docker file, if you put that Docker file in your GitHub repository, you've got to maintain that Docker file. So if you see a Docker file, somebody gives you a Docker file, if I throw you a Docker file, what are you going to do? Bat it down. Bat it, just bat it, don't touch it, bat it down. Build pack is the way to go. Why? Why, DaShaun? Why is that? I'm going to give it my source code, and I'm going to get all the benefits of what's going on in the org, all the best practice in one Docker image build pack bundle. and everybody gets it. Now, an additional benefit of that, the idea of a Docker image, a Docker container, it's got layers all the way down. I'm going to simplify. We got an OS layer, right? Docker file from image OS layer. Then typically there's a runtime layer, Python or the JVM, and then there's your app code that goes on top. Real simple case, 3 layers. But if I'm using build packs in something like Azure Spring Apps for Enterprise, if a CVE comes out today, I'm sure somebody had to redeploy something from a CVE today. If a CVE comes out for that OS or the OS layer or the runtime layer, the JVM or the OS, if I'm using Azure Spring Apps for Enterprise, I can update all the apps that were created using that build pack without having to redeploy anything. I can literally take the OS layer out of all of those deployed images, plug the new one in at runtime, build time, in production. That's cool. If you're at massive scale where you're delivering hundreds of apps across hundreds of regions, that becomes really, really effective. Hey, yeah, that new 0-day just dropped. Like, how long does it take you to get that fixed? One of the benefits, again, under the covers of Azure Spring Apps for Enterprise. Why I like it. We were talking earlier about COBOL. You can have these build packs for just about anything. If you go to, actually, I can show you. We can go to cloudnativecobol.com, right? Cloudnativecobol.com. I made a build pack for COBOL. So if I were to deploy this to Azure Spring Apps, I could run this build pack. I could say, hey, Azure Spring Apps, deploy, actually not Azure Spring Apps, but I could say deploy, use this build pack to deploy this COBOL source code. And it'll bundle it up. The other part of the build pack is going to bundle up and it's going to give me an OCI compliant image, a Docker image that I can run on Kubernetes or Docker or on my laptop. They're not that complicated. That didn't take that long. So I'm just feeling like a lot of times, like, yeah, but what about our language and what about what we're doing? And we have special stuff. You can put it all into your build pack. The one thing that I've learned, again, working with all these organizations all over the world is like, inside of an organization, this is my favorite. Let's just say we've got 2 business units right here. I could go to one business unit and say, who's the Jenkins expert? Of course, somebody's going to raise their hand. I'm the Jenkins guy. I do all the Jenkins stuff. I know all the pipelines inside and out. And I can go over to this org. Next floor, next building. Who's the Jenkins? I'm the Jenkins person. It's me. We've got the nice layouts and all the cool stuff. They're duplicating work. 95% of what they're doing is the exact same. And depending on the size of your organization, literally there's hundreds of these people that are doing the exact same stuff, just in different buckets, in different resource groups, in different clouds, but it's the exact same thing. Build packs. Make it simple. Centralize. Again, therapy session. Like I was that person that was putting this magic into each repository. Each repository had its own build process, and it knew how to get to production. And I was like, this is great. Like, nobody's going to get in my way. I knew exactly how I was going to weave and navigate all the policy and all the process and generate my F5 rules in every repository. But then, when something changed, I had to go and change every single repository. Yeah.
Hopefully this is a short answer. You ended up, I see you're on a Mac.
Oh my! Look at this. It's like you knew me. I know what you're going to say. You're going to say, hey, I wrote an M1. Oh my goodness. Oh my goodness. We can take a quick little diversion. Look at this guy. GitHub.com, DaShaun, Paketo ARM64. This is a multi-architecture build pack. Oops, sorry. This is an x86. I run an M1 at home. I started this process years ago when Dave Sire was like, hey, this is cool. We've got this Spring Boot plugin that's going to generate your OCI images. Maven, Spring Boot, build-image. I was like, this is great. And I called in. It was a webinar. I was like, hey, can we do this on ARM65 or ARM64? He's like, I think so. Here's all you need to do. No. I'm going to go do it. Duct tape, bash, all the way. But I made it work. I was building images of my Spring Boot apps for my Raspberry Pis. Oh, man, this was sweet. This was sweet. Again, my children will never deploy active passive. I don't have a lot of money. I got Raspberry Pi money. I got that. I got Raspberry Pi money. Yeah. Hey, you can have 3 of these $5 computers, right? So that's where it started. My good friend Daniel Makusa came along. He's like, hey, here's a better way. I'm going to show you how to build this build pack the way that Paketo does it. He created this project. I forked it up there a long time ago. My repository looks nothing like that anymore, but he started it. Like, I got all the inspiration from him. I took my ugly, cobbled mess and turned it into this. I'm going to add on to that. This build pack supports ARM64. It creates 2 images, an ARM64 image and an x86 image, and at the end, glues them together into a multi-architecture image. So if you ask, if I use this build pack, it'll actually generate 2 images, glue them together in a manifest. So if you're on an M1 and you pull down DaShaun Dev Service Gateway, you're going to get the ARM64 version out of that manifest. And on this one, I'm going to get the x86 version. So the answer to your question that I'm so thankful that you asked, even though it has nothing to do with the talk, yes. And I'm working with Daniel Makusa and the Paketo team to get that upstream. So Daniel already has the stack, that base layer of the detect and run phase. He's done that, so now that's multi-architecture. So that we're getting baby steps so that when you do a build image, you can actually build one or the other. I've got pipelines, and I'll show you that just because we're here. Where in one case, here's what I do. On the GitHub Actions, they're on x86 runners. Go. I use the same build pack. I use the same DaShaun builder. And then for the ARM64 version, I run it on Circle CI. They've got ARM64 builders. And when both of those processes are done, I glue them together. So everything that comes out of this repository is multi-architecture, ARM64 and x86, because it uses that build pack that we just looked at. So, wow. Now let's talk about, again, I don't like to spend a lot of money on infrastructure. The idea of, it's not just the M1, right? A lot of us are still on x86. A lot of us are switching to M1. So this is just keeping my developers happy, keeping my team happy. I get all this benefit of these build packs. I want you to be able to run it on your laptop. But now let's talk about in the cloud. I know Honeycomb is here. Honeycomb did this report a long time ago where they were switching from x86 VMs to ARM64 VMs. Like just out of the gate, on a lot of these clouds, you're getting a 33% savings on your infrastructure. Right? That's like MSRP, sticker price, 33%. Changed in the VM. A 4 gig or a 4 core, 24 gig VM in cloud that's running on x86 is $100. That same thing running on ARM64, 4 core, 24 gig, $77 or $67. Like that much savings. Now you do that for your apps, for your workloads, running the build packs. Same, validated on both sides. They might even work better. They might even perform better. You will definitely get a pat on the back. Definitely get a pat on the back. Save your org 33% off the top on some set of workloads. You will get a pat on the back. All right, I digress. This is what we're doing. This is what we did. We pushed. So we had a build pack. The platform ran it. I didn't do anything. I got source code. The platform's doing it. It deployed it. Did I answer your question? Oh, thank you. So I deployed this app, and my app runs in North Europe. Way over there, North Europe. I think it's in the UK. All my app does is, hey, like, let's run it. You guys can run it too. Feel free. I'm going to put a key in that database over in North Europe. But if I did something like this, if I grab more tools, I also love without my glasses, so I'm having a hard time seeing. Let's do this little thing. Who knows what's going to happen? I'm going to do this a few times. We're just throwing some keys into a data store over in North Europe. And my boss comes back, he says, 229 milliseconds? We can't make any money at 229 milliseconds? That is way too slow. Latency is the new downtime. I worked with customers while I was at Redis. This matters. If your company is getting paid per transaction, whatever it is, and you can cut from 2 millisecond latency on your data store down to 1 millisecond latency on your data store. You have the potential to make twice as much money. I've run into this. Massive, you get scale, and hey, yeah, our data store can only do this much. And you get up to this certain level of capacity where you've got to spend millions to add some more stuff into the data center to get you like 5% more headroom for the next year. And there's this metric that I like to use, cost per transaction. Cost per transaction. If I'm taking transactions at 229 milliseconds, and my infrastructure costs this much, but if I can increase the number of transactions on the same infrastructure, my cost per transaction goes down. Think about it, hear me now, listen to me later. Cost per transaction, this is where I care. A lot of the customers that I was working with was, this 2 millisecond latency on our data store is not fast enough. We need it to be down here in the 1 millisecond latency. This is why not every workload, but the ones where speed matters and we can do the eventual consistency, like there are a lot of workloads where this is a great solution. But this is what we did. What happens? So it's not just about resiliency in this case. We're here in the US. We can't afford this. We can do a couple of things. We could move to the US and say, hey, you know what? North Europe's not working, most of our traffic is here. Let's bring our workloads here, right? Let's bring our data to where our customers are. That's a valid option, right? Like just pack up the zone, bring your stuff over to the other cloud that's closer to your customers. It's an option. It's definitely an option, depending on where you are. Well, for you guys, for this audience, we're going to do more. So, North Europe. Did anybody hit that? North Europe? Good? It works, yeah? Good. So, this is we're in Azure. I've got 2 resource groups. They're both in North Europe. One just has my infrastructure, my app insights. Oh, and my front door. We'll get to that in just a sec. I want to make this better than just one region. I want to make this better. I want to improve the performance and give myself more capacity. I tried to scale this out a little bit better, but if you go into the repository right now, you'll see that I'm only doing 1 instance in each region because I didn't have my quotas set. So I apologize. I couldn't do any more than that in each region. But if I only have 1 vCPU in each region, again, there's another workaround. I can put in another region, and I get another one. I can scale out into another region. Make sense? That's what I'm doing. So I also deployed Redis. Redis Enterprise, specifically. And Redis has this cool active-active thing. What I can do is I can actually deploy Redis Enterprise in, the last time I checked, it was 5 different regions across Azure. Like, multiple regions are available, but I could do up to 5 in this active-active configuration. I could link up to 5 databases. And this is what it looks like. I'm really just saying, hey, I'm deploying these things. I've got a couple clusters. I want to be in this active-active. And it changes the data type that it uses from being just a regular key to a conflict-free key. So if I have writes, exact same time, different regions, exact same thing, it knows how to resolve that. Each data type has its own resolution scheme. But yeah, that's way deep. We're going to stay up here a little bit. But it takes care of it for me. That's cool. So now I've deployed, I'm going to go back here. I'm going to show you my resource groups, and I'm going to do magic. I pulled it out of the oven. I deployed the exact same thing, the exact same app, similar infrastructure. I deployed it into South Central US. So now South Central US is up. Let's go take a look. South Central. Remember, I'm putting the key of where I hit. South Central, it worked. South Central is up. So now I've got stuff in North Europe. I've got stuff in South Central US. And the databases are linked. So when I write something here in South Central US, it's going to show up over in North Europe. List. Cool. That list took 774 milliseconds from North Europe. Let's see what it looks like over here. A little bit closer. Oops, I didn't do the thing. All right, this makes sense, right? Does everybody agree latency is the new downtime? That's a big difference. 150, we're closer. So I should go back to the world map. We are closer to the South Central US than we are to North Europe. That's why this is faster, okay? So, cool. Like, hey, DaShaun, like, you haven't really shown me anything. What I'm showing you here is I've got 2 data centers, different parts of the world, that are running the exact same code. I didn't have to do anything magic in my code to make this happen. Spring Boot, Spring Data Redis. I showed you the POM, super easy to do. They get their configuration from the environment, one of those cloud native principles. Or my app shouldn't care, it shouldn't need to know where it's running. It'll find out when it gets there. So if I took the same one and I run it in Asia, it'll run and it'll say, hey, what region am I in? Cool, I'm ready to go. That's what I'm showing. This is all making sense now, but so my US customers right now, they have to go to the South Central US, and my Europe customers, oh, so let's make that better. Front door, we saw it. I added a front door. What does that look like? It's a gateway. Spring Cloud Gateway works much the same way, so I'm always kind of mapping to these smaller abstractions, but this is how I think about it. I've got front door sitting in front of these applications, and these applications, here, I've got location 1 dash beautiful, location 2, South Central and North Europe. And it says, hey, I want to check, is it healthy? Can I send traffic there? Let me check. I'm going to hit that actuator endpoint to see if it's up. Let's go look what that is. Actuator health. And that one says, yep, I'm up. I can take traffic. This is a great pattern. If I can't reach my database, no, I cannot take traffic. Don't send me any traffic. If there's any problem, I can put these health checks in place, say, don't send me any traffic. Makes sense. I'm going to do the same thing over here, South Central, actuator health. Good, we're up. All right, so far so good. Makes sense. So now we've deployed a front door that's checking the health. Every 5 seconds, it's checking. Every zone that I put out there, 5 seconds. Hey, are you good? Are you good? And if you're good, I'm going to send traffic. And front door is actually the one that decides which region I hit. Watch this. I'm going to go, I get an endpoint, Philly ETE-front door. I hit refresh, it hits South Central. And then if I do it again, South Central. It knows where I'm at. So as you can imagine, my customers that are over in Northern Europe, they hit that same URL. They're going to hit the Northern Europe location. It seems like a lot of enterprises are already doing this in some way, shape, or form. Right, there's some layer up at the top that is doing all the routing and the magic. Right, some CDN, if you will, some front door type thing. Tons of options. But it's not really that complicated. The abstract is there, the abstraction is there, but it's not really that complicated. It's fairly easy. So we deployed a place to run my app, my Spring Boot app, a data store, and a front door. My data store is doing all the synchronization between the zones. And let's go make sure we have all of our data. Cool, it's getting values from both regions. It's active. No matter where I write, I'm going to see it on both sides. But now, this is the magic part. Let's do this. Let's go and let's do this. Let's hit this region. I'm going to hit this button. What does this button do? Delete. What do I got to do? Delete. What could go wrong? Game day. Game day. Let's just delete the whole region. What could possibly go wrong? Right? It's going to do its thing. Yep. So it's deleting not just the Redis Enterprise data store, but also the Kubernetes cluster and all the magic that went in it. Just delete it. And then let's go and let's see, is it up still? Uh-oh. My south region is down. Now what? My health check is not even responding. Please work. Oh boy. Every 5 seconds. Remember it says every 5 seconds, so we got a little time there. Hopefully this is going to work. What could possibly go wrong, right? Oh boy. Well, sometimes it works. Sometimes it doesn't. Right? I told you I made these changes this morning, and it's because I don't have my glasses. That's really it. So this is where I dance. I'm like, hey, this is what we did. This is what it looks like. It's beautiful. Spring Boot, Spring Cloud. Let's do it. We had our single region. Our single region worked magically. We put that front door on top. I've done this before with the 5 regions and the health checks. All the same. But it's that data store layer that's magic. We had both regions. We showed that. And the global DNS. That front access gate. My children will never deploy active-passive. I would rather them get a 404 trying to do it active-active than deploy active-passive. So what this was supposed to be was a Hello World enterprise-grade 99.999% uptime demo. I'm going to give it one last try. Yes! Yes! All right. I'm not sweating. You're sweating. That's it, right? That's the thing. Stuck the landing.